Hello everyone. Today we gonna have the different video. I'm reading the paper from Google. They introduce the scalable data warehousing with robust query performance at Google. So, as the data architect, I need to have I have to design the robust system, robust data system, and I went through the Google because as Google services, they generating a lot of data. Vast amount of data will be injected and generated by the application or services, and they store into the data center. And I just figured out this paper. So this paper they introduced the Napa. Napa is the backend for numerous client in Google. The client have the strong expectation of variance-free, robust query performance at the core, and they Google designed the principle for Napa technology by using the material live view, which maintains consistently as the new data is ingested. So I think this is the delta data because at the time the data ingested, so they need to ingest the delta data. Only delta data will be injected and updated into the system. So and create and maintain the visual live view. And the client also demand flexibility in being able to adjust their query performance, data refresh, and the cost. So I think this is the trade-off. Because if you know about the gap diagram, this is all the same. The query performance, data refresh, the query performance mean how fast you retrieve the data from the system. Data refresh is the how old data in your system, and the cost is the money that you spend to running your query or running your system. So that I think that's very interesting when they considering those pillars into the designing of the platform. So the robust query performance and flexible configuration of client database. So I think that really very interesting. This is the only introduction about the Napa. We gonna skip it. Oh, this is the a new design replacing the Mesa earlier Google system. So I think this is very interesting. Even in Google, they always have the migration problem when they migrating the data from the legacy system called Mesa, and then they designing a new system for their client, support a million user, terabyte, petabyte of data, a lot of data, a lot of historical data need to be on board for many new client. Okay, that's very cool. Let's see. There is the client requirements are purpose query performance. Consistent query performance is critical for data analytical. Yes, this is very lower expectation from all client that we got. Like the query needs to be very fast. The SOA maybe just 1 or 2 is a 1 or 2 minute, or even for the streaming data, the expectation was just 10 or 15 seconds. So that's a very strictly requirements from the client that we got in the past. And the flexibility while performance is important our client experience, so that it is not only a criterion for our client, so performance at any cost. So this is very interesting requirements, because even you had a good performance, all the solution was the changing the cluster size, like up the cluster size from S to M or M to L, but they need to maintain the cost. So that's a very interesting. And also how to put data injection. So that is the very important thing. Like when they injecting the data from application or services, they need to maintain the material view and indexing all the data, and how fast the data will be injected into the system. That we call the delta data. And in the Google Napa, they use the log structure merge tree to maintain all the tree or delta data. Like if the delta data is merged into your system, that is just only the delta data. And that's cool. That's cool. And the client need flexibility of all the balancing that we need to balance in the data reference, resource cost, and query performance. That's cool. And let's see how they design it. Oh, they design choice made by NAPA is they have layer architecture. They have just three. Basically, they have three components in the NAPA architecture. The first one is the instruction. I think this is the instruction framework. Okay. Okay. Instruction framework is responsible for committing updates into the table. So updates into the tables mean that delta data will be injected into the system. Data written into the by the injection framework on itself to satisfy the durability requirements of the injection framework. Okay, and storage framework incrementally apply the update to the table and their views. So only the delta data will be updated in the table and create materialized view. Mean that materialized view always refresh, and they need to maintain the SOI. I mean the data refreshness. Like you can imagine the data refreshness like how old the data in your system, like that you have the last month data in your system, or you have the last 2 months of data in your system, that's 2 months or 1 month always available for your query. And they have the query serving responsible for answering client query or client question. And this is a materialized view, the basic. Okay, NAPA decouples injection from view maintenance and view maintenance from the query processing. Like I said, this is the layer architecture, and they call it decoupling. So that anyway, that would should be the trade-off between those um, pillar points. So data frame management, resource cost, and query performance. We need to do some kind of trade-off. They introduce about the curable timestamp, provide the client with the line marker. Okay, like I said, the data refreshness have the time limit, like 1 month or 2 months of data. This is the now managed to the curable timestamp. 1 month or 2 months, that is how old the data are sitting in your system. That would be the curable timestamp basically. Curable timestamp. They have the control plan and data plan. um, I mean, control plan mean when you run a query, they have the optimizer or the planner to format your query, make sure all the queries are good for the system and readable by the system, and create a plan execution and validating all the query before they execute on the data plan. So in data ingestion framework, always ingest the data into, and this data is a non-queryable, mean the queryable timestamp exclude the non-queryable data injected by the instruction framework. You need to imagine how the flow is. The instruction framework will ingest new data into the system, and that data is not available for query. Other other thing is, if the maintainer materialize view run the query update the data merge into the queryable data storage, you have the data on the um, materialize. So that very tricky, and we need to have some trade-off. This is a sample of trade-off query performance, trade-off cost. There are all the um, example that very interesting. System architecture, because I think high-level architecture consists data and control plans and multiple data center to manage the replica edge data center. So I think that's a very simple design by the big platform like Google, Azure, or AWS. They have the replica for data center, and they mentions the couplings strategy, the couplings approach. But people leverage existing Google infrastructure and components. And yeah, yes, that makes sense. Uh, Injection Sweden approach. Okay, they have the batching, sorting materializations, injection into the system, replica data, and they have the metadata to maintain all the meta of data. So let's see instruction responsible for inserting update into the table. This all the example that I just explained to you. Query per timestamp decoupling query performance. Like I said, older delta, recent delta is 1 day, and non-curable delta, reference delay. Okay, is it X delta each month? So just this visualization is very easy. Like is the is assumption this is the when you run a query, and this is the 1 day of data, and this is only this is the reference delay that you can query the data into this data timestamp, but otherwise the older data will not be available in your query system. Oh, they use F1. I'm not sure what is the F1, but I think there's a for they have the separate engines to query to run the query. They choose to use the Google F1 query as the original data pump to compact the table and maintain view. Like, I think this is the system to maintain all the query optimizer, like the control plan. They use the F1 to optimize the query, running all the maintenance um, and running all the operation in the view. Make sure the data will be merged and available for query. Pre-planning to avoid the data skew. Data skew is very familiar term when you're working in the distributed system. And if you don't know, just research about the data skewness and using Spark to rebalancing or repartition the data skewness in the data set. That's very familiar. Okay, this is the flow. The query run into the F1 server, like I said, run it partitioning F1 worker, split into the subquery, create the execution plan, and they store the metadata into the server, Delta server, distributed cache, and in Napa data center they run the query. Okay, and in the query in the table they have the index and delta data. This query service performance, and I think that's all is the benefit of the Napa system. The runtime tells and failures, how they handle the failure, non-streaming, remote procedure control, number of view added, number of deltas. I'm not sure about this point, but I think this is the diagram that they show the query latency. Is it a query latency that showing if we add in more views, the query latency will be reduced. And this is the latency number of delta. If we have the multiple delta data, that would be increase the latency. But to avoid the delta data, we need to have the system that we compacting all the data. That means we compress all the smaller file into the bigger one, at least 100 megabyte per file. Then they optimal for query performance. That is the best practice. Analytic coupling related work comparison with the meta. Napa is designed to be a drop-in replacement of Mesa, and hence is a multi-tenant, multi-home distributed global replicated data management system. And I think Napa already replaced the Mesa because it introduced the paper. They need to be work on this. So the conclusion is Napa is an analytical data management system that serve critical data Google dashboard. I think GA4 is using the Napa. I think so. For application internal user, some way is compatible to all the relevant system, high scale availability, total application failover, high user query load, large data volume. That I think that's all. That's all about the NAP architecture, and I'm not sure if you really love this one, but instead of reading the high level architecture, how the X company handle terabyte of data, we better than you read the white paper. If you are a fan of the researcher or a fan of researching through the papers, so I think this is really good. Beside that, I think we can gain a lot of knowledge about the overview of the system, how the X company handle X terabyte of data, or how they handle X um, data sources, um, at hundreds data sources. But anyway, uh, we can use either paper or the article to understand how they design the system, how they made the trade-off to choose the technology and category of the system design. Um, so yeah, I think that's it for this video, and I think we got to have pay more time to read this paper, and yeah, if you have any opinion or just leave a comment in below, and see you in the next one. Bye bye.